Okay, hi again. Uh, Welcome to another week, and excited for us to go through a few things today. And I mean, over the course of our time together, if you have any questions, please feel free to stop me anytime and ask your questions. Just to give a recap of the things we'll be covering today. In today's class, we'll review objects. We'll briefly talk about the DOM, and we'll review APIs. We'll learn about promises, async, and we'll tie it all together in asynchronous function. So we have quite a lot of things to get through today. Hopefully, it's a wonderful time together. By the way, can you hear me very well?
Yes.
Okay, great. So, again, if you have any questions about last class or life, by me, we spoke about it earlier, there were no questions. So we'll just move on. We just move on. Okay, so I mean, I just wanted to reiterate this again. When we started our time together, I mean, we spoke about how when you start, I mean, because there's novelty and everything, there's excitement to learn and everything. But as you go forward, you realize that this is actually hard work. So then you get to the point where the chop of sorrow, things are not making sense. You don't totally know what you're doing and all those things. But like we spoke about it extensively when we began, it's just normal and it's expected. So if you're at that phase, just remember that it's all part of the process. And the promised land is at the end. So not to give up. Things are not making sense, keep at it, take breaks, continue to be consistent, and hopefully, and it's only a matter of time before we get to the promised land. So just a reminder about the trough of sorrow. The thing we spoke about was the forgetting curve, in the sense that it's very likely that the things you forget, you learn, you forget. And we looked at the Ebbinghouse's forgetting curve when it says that we forget 58% of the things we've learned 20 minutes after we've learned it. And by 31 days, we'd have almost forgotten everything. So we spoke about how you want to consistently reset your forgetting curve. And one of the ways you can do that is to use spaced repetition and active recall. So spaced repetition, where you are reviewing things after a period of time and you're consistently trying to like go over the things you could do. And we said one of the easiest way we could do that was to use our Anki. I showed how I did my Anki card. So just make Anki cards for everything. So the things you review after today's class, put it in your Anki. And every day try and do your Anki. Anki has an algorithm behind it that spaces the cards you review today so that it'll pop them up after a number of days. So tomorrow the things you review will be different from the things you review today, just so that you're consistently resetting your forgetting curve. So I mean, I wanted to reiterate that Anki is very important because most of the things we learn is a lot. I don't expect you to remember all of them, but consistently, as you're like doing your Anki and stuff like that, you're increasing your likelihood of not forgetting the stuff, remembering the things, and then you're able to use it. So that's the thing I wanted to share. The other thing I also wanted to share was I know we've learned a lot of like fundamental JavaScript and like programming language stuff. And right now, the most important thing is to consistently practice. Now, Code Wars is a great platform for practicing just basic coding stuff. So I'll just show you how Code Wars work quickly. And every day, try and do like one code word. It'll just help you practice the things you're learning and like it'll give you questions. You try to solve it with code. It'll show you if you're right or wrong and stuff like that. So I'll just pull up Code Wars here. So okay, let me drag this to. So this is Code Wars. So when you create an account and everything, you should have an interface like this. So when you come to practice, and hopefully the internet doesn't mess up, but when you go to practice, there are different questions.
Oh, your line is breaking a bit.
Uh, Let me know if it's stable.
Yeah.
Is it stable? Uh, I'm coming. Let me close some
Yeah,
stuff.
yeah, it's better now.
Okay, sorry about that. Uh, can you hear me?
Yes.
Okay, great. I guess I have too many tabs open. So when you go to CodeWars, you have an interface like this when you create an account. So what you can do is you can sort the different things. CodeWars, they rank the problems by difficulty. So at the beginning, you want to start with AKU and just filter for uh, uh, problems that are 8 KU. So when you come to difficulty, you can just select this and search for problems that are only 8 KU. Another thing too is that all your problems you'll be solving will be in JavaScript. So you don't have to worry. You just have to set your language to JavaScript. Then what you want to do is you can also just filter by different things. So if you want to just do like string problems, you could just search for string problems. You could just do only strings and stuff like that, just so that you're consistently like practicing the things that we talk about. And what I liked to do in the beginning was I'll spend like only like 20 minutes on the question. If I can't solve it, you can view solutions. So you can look at how other people have solved it. That way you get like familiar with how people are doing it. The thing about code, a lot of people use a pattern called regex. Ignore all the regex solutions because it's like a shortcut. You don't really be learning anything. So when you go to like, let me just go to this feast of many beasts. I don't know what it is. Okay, it's a string problem. Uh, okay, uh, I should think am I breaking up?
No, no.
Okay. Yeah, I wanted to open this, but I mean, it's taking a while to load, so I just close it up. But when you go on Code Wars, you can find like problems to do just for this month or for just do 8 KU problems. Don't worry about doing like very difficult problems. Just do 8 KU problems. I mean, if you can't do it, just view solutions, see how other people have solved it, or just get you into the pattern of like how you are solving the problems with like the things you already know. That will make it like easy for you to know how to actually apply like when we learned about like the for loop, how to actually apply a for loop, things like that. So I try to do one code where every day and eventually you get familiar with like how you are using the methods and things like that. So that's the last piece of information I wanted to share. Okay, so just to jump into what we have for today, the last time we spoke about objects, we spoke about how they are primitive data types in JavaScript. There are 7. But object is a data type, but it is not primitive. The reason it is not primitive is that it can store multiple things. And we said an object is used to store a key and value. So it's a key, it's used to store keyed collection. So all that basically means is that in an object, you have a key and a value. So in very simple terms, if you want to declare an object, and let me just quickly create a folder, objects, and let me create a main.js. Main.js. So what we said an object is just key value pairs. So let's say we had an object called user. So in user, and we said the way we declare an object is we can use the object literal, which is just a pair of curly braces. So a key value pair. So an object can have the name. Maybe so we're creating a user. User can have name. Name can be Cornelius. Age can be 100. 100. Then I guess nationality can be Ghanaian. So this is just an object. This is an object with the name, keys, and values. So that is basically an object. I hope that made sense the last time. So objects are used to store key and value pairs, key and value pairs. That's the big definition of what objects are. And I guess the other thing I just have to mention is that object variables are called properties and object functions are called method. That is big English for the sense that this is a variable. So if you have a variable in an object, you say it is a property. Because if I was going to declare a variable, I would have done maybe const name is equal to. But if it is in a variable, you say that this is a property and this is the value. So by default, I can still access this. So if I do console.log user, if we're trying to get the name user.name, And if I save this and I run it, if I run it, main.js. Okay, I'm in the wrong folder, sorry. CD objects. I think I called the object. Okay. So if I run it again, we can see that the username is Cornelius. So these are just variables inside an object. So we say they are properties. So they are properties of the object. And in the same way, we said methods are functions in an object. So the same way we have functions, we can have a function in an object, and we would say that is a method. So we can say something like maybe get last age. So how old they were last year, and we could assign it to a function, and we could say we'll return the current age, so age minus one. Sorry. So we'd say age minus one. So this is a function tied to an object. So we say this is a method. So if we were to get the user dot get last age, and if we run this, you see it says it's a function. So it's a function tied to the object. So it's just, I guess we can just run it. It is not defined. Oh, okay. No, I shouldn't be calling it. So sorry, I put quotation marks. Clear. So if we run it, we see that it is a function. So we would say it is a method, and we say this is a property. So properties are just variables inside of an object. Methods are just functions inside of an object. So just so when you see methods and you see properties, just so that it makes sense. Any questions so far?
Can you go to the VS Code?
1 second. Okay, yeah.
Is there any reason why, like for the function, you put the age minus one down, or like on the next line, or it's just for aesthetics?
So this why I put this on the next line.
Yeah.
So I mean you could do it like this. I mean you could have everything on the same line, but so you were saying why didn't I have it like this?
Yeah, well, because that's just what I like, because you are talking describing the function, then that's just what I assumed. But I was just curious.
Yeah. So it's just so I have a formatter, so it just formats it so that it
Okay.
presents it nicely. But I mean,
Okay.
I usually always put like my function body on the next line. Like I like to put it on the next line just so that it's like I can see what I'm writing rather than having on the same line. But usually,
Okay.
if you have like just the same, like it's just one line, the function is just one line. It's okay if you have everything on the same line. But usually, that most times when you're writing a function, you have like several things. So it's probably better to just bring it to the next line so that you can like keep adding and adding and adding. But it's just for aesthetics.
Yeah.
It doesn't really affect how it runs. Yeah.
Okay.
Okay. So back into the slides. Yeah. So I mean, I had an example here of how you want to think of an object. So if you were to think of an object in real life, can we have like an example? Give me like an example of an object in real life. It could be anything.
Mm, hmm. Um,
I mean, I think your phone is an object. So I mean, objects are everything. So phone,
okay.
yeah. It's not like programming stuff, but just like in real life, any kind of object. So think of let's use your phone for an example. So for your phone can have properties like the color of your phone, what type of phone it is, like is it an iPhone, is it a Samsung? So it could also have, I mean, those are some of the properties that comes to mind. So those are some of the properties of your phone. It can have some methods like make a call. So you can use the phone to do something. So you can use it to make a call. It can have a method like take pictures. It can have a method of like record a video. So those are some of the methods of your phone object, and some properties can be like the color, the brand, things like that. So that's the way you want to think about it. Those are like an examples of like properties are like descriptions about it. Methods are things that it is doing, so that would be like a function. So I had an example of I had an example of like a stopwatch. So for like a stopwatch, you can think of like the color, the brand, what type of watch it is. Then you can have some methods. So like start, because it's a stopwatch, you want to start it, you want to stop it, you want to reset it. So those are like examples of methods. And like you can see, most times methods, they have the closing brackets, because when it's a method, you're usually calling it to do something. So that's how you want to think of an object. So the properties are just like things about it. So the way you access the properties is like use the dot syntax. So remember when we're in the VS Code, when I wanted to access the name of this user object, I could just do user.name. So I can use the dot syntax to access a property. So I can do user.name and it returns Cornelius because the user's name is Cornelius. I could also use the dot syntax to access the method that sends stuff like that. So those are properties and methods. So when you hear properties and methods, don't get to confuse. Properties are just like variables tied to an object. Methods are functions tied to an object. Does that make sense, please?
Yeah.
Okay, great. Great. So I mean, just to go over the ways you can create an object. So you can create an object by using the new an object constructor, or you can just use like a pair of like curly braces, which is called object literal. So you can just use the curly braces, and whatever you put in will be an object. So these are the two different ways you can create an object. Okay, any questions before we review document object model?
No.
Okay, great. So the last time we spoke about document object model, and we said that it is an interface for web documents. So it represents our page so that the document, we can change the document structure. So we said when we have a page and we open it in our browser, what we see is actually a representation of our code. So our browser creates a document of our code. And because it becomes a document, now we can make changes to it. So it becomes and just remember, we just spoke about objects. So it's just a document object model. It creates an object representation in a document form. So we can in turn go into it and make changes using different properties and different methods. So tapping into like the different properties and methods that comes with the document object, we can make changes to our page and make it dynamic. So by default, we said when it passes it as a document, it creates like a tree-like structure. So usually you have the root being the HTML, you have the head, you have the body. Inside of the body, you usually have like different elements. You have like H1s, you have sections, then you have like the actual text, what you've written. And in the head, usually in the head, we have like the title, metadata, things like that. So that's how your browser breaks it down. It breaks it down into like a tree-like structure. So you can go into each of these nodes and make some change to it. Okay. So we said documents represent our web page, so we can make changes to it. We can access things. And we said the document object model comes with like different methods and properties. So we spoke about the inner HTML. We spoke about get element by ID. We spoke about get query selector. So these are just like different properties and methods. Because the document is now an object by default, it has like properties and methods. They are not ones that we are setting. Like when we created the user object when we created the user object a few minutes ago, we gave it our own properties and we gave it our own methods. But the document object model comes with default properties and objects that we can use to do different things. So these are some of the properties and methods that come with the document object. So we can use these things to do different things. We can use inner HTML to change the HTML. Can use get element by ID to grab an ID from our HTML and do things with it. I hope this part makes sense. This is a review of some of the things we spoke about previously.
Yeah.
Okay, great. Okay, we also spoke about events. We said events are things that happens in our when we are programming, so we can use events to do things. So we can be like when a user clicks something, do something. When a user changes the size of their screen, do something. When a page is downloading, do something. So those are just events. Okay. So what we want to talk about for the rest of our time to get that today is talk about synchronous and asynchronous coding. So we briefly mentioned that there are two ways. Most programming languages are either asynchronous or synchronous. And by definition, when something is synchronous, synchronous relates to time, chronos is time. So synchronous means that it is doing one particular thing at a time. So before it can move on to the next thing, it has to finish the first thing. And when we say it's asynchronous, it means that it can do multiple things at the same time. Now we said JavaScript is single threaded. So that's the new bit of new information. JavaScript is single threaded. What that means is that JavaScript has a single thread. And because JavaScript has a single thread, what it means is that JavaScript can only do one thing at a time. So JavaScript cannot do like multiple things at the same time. So if we have this function, for instance, we are console logging starting, we are running a function, and we are console logging done. Because JavaScript is synchronous, what will happen is that it will do 1, 2, 3. And we can see that here, there's something that it has to do. So it has to get what date it is right now. Then, so we are storing what date it is right now, so the time. Then we want to get the date right now and wait for 5 seconds. So by default, because JavaScript is synchronous, it will do this console log starting, wait for 5 seconds before it does the last thing, which is console log done. So if this was 1,000 seconds, if it console logs starting, it will move on to the next thing. While this one is counting that, it will wait for this to finish whatever it is doing before it will console log done, and we'll run this code later on just so that we see how it is working. So JavaScript is synchronous, which means that it can do one thing at a time. Okay, does that make sense? Hi, can you hear me? I hope, am I breaking out?
No, no, no.
Okay, cool. Yeah, so that's one thing at a time. And we tie all this back together. Let's talk about asynchronous. Okay, so the way I like to think about it is think about it as like a paper boy delivering papers. So if they are delivering papers synchronously, what they have to do is that when they get to whichever neighbor they are delivering the paper to, they have to go to their door, knock, allow the person to come out, give the paper to them before they move on to the next house. So they have to keep doing this, wait, finish, move on, wait, finish, move on. So that would be a synchronous way of delivering papers. Now, an asynchronous way of delivering papers can be like when they get to the door, they can knock, leave the paper, move on to the next house. So they don't have to wait for the person to come and take the paper. Or they could also just throw the paper like the way they do. Like just throw the paper, move on to the next house, keep throwing. So they are not waiting for the person to come and take the paper before they move on. So that would be like an asynchronous way of delivering papers. Okay. Okay. Yes. So that's the way you can think of synchronous and asynchronous. So synchronous, you wait for one thing to finish before you move on to the next thing. Asynchronous, you don't have to wait for the next thing to finish. You can just start and move on, and maybe you can come back to it if you need to, but you don't have to wait for it to finish immediately. Okay. So I just had this definition here. So asynchronous code is code that doesn't block the execution of subsequent code. It allows multiple statements to execute at the same time, which can improve performance. Instead, it uses callbacks or promises to handle the results. And we'll get into callbacks and promises today. But asynchronous code is just code. It doesn't block the subsequent execution. So if one thing is running and it is taking time, it'll move on to the next thing, keep doing the next thing until this current thing, which was taking time, is done. If this current thing, which was taking time, is now done, then it'll come back to it, do what it needs to do with it, and keep moving on. So it won't wait for it to finish. So synchronous code is one thing at a time. Asynchronous code is or move on if it needs to without waiting for this thing to finish and come back to it when it is done. Yes. So let's run this code that I had earlier. Okay, so I'll just run this code, and I guess we don't need this object thing, so I can just run this. So basically what this code is doing is that, first of all, we said if it's synchronous, it's doing one thing at a time. So the first I guess execution we want is that we want it to log something. Then we want to run this function. Then we want to run this other function. So we don't need this. So we want to run this console log, then we want to run this function, then we want to run this. Now, by default, this thing is going to take 2 seconds because we are just taking the current time, we are storing it in a variable. Then we are deducting and saying that if it is not less than 2000. So when we take the current time and we deduct, we want it to be less than 2000 milliseconds. So we're just waiting for 2 seconds. So if I log this and keep an eye on the console. Let me clear this. Sorry, clear, not, I don't know why I spelled clear like that. So I want to, let me just clear this thing. Let me save this. Let me save this. Now, if I run node.js, you see it says starting. Now, you can see that it took a while before a console log done because then it was waiting for this function to finish running before. And maybe let me increase the time so that we see that it takes a long time. So if we run this again, we can see starting. Now it is done. Now you might be like, why is this a problem? And I have this simple code here that we can run. Okay. So by the way, did you see the execution? Did you see how long it took?
Sorry, I was muted. Yeah.
Yeah. Okay. So because JavaScript is asynchronous by default, it just does things the way you've ordered them. So we'll do what you have first, what you have second, what you have third. Now, in this example, I grabbed from the MD and we have, and let me just open this. And I mean, with this, don't worry about the syntax or anything, or let me just open this here. So in this example, we are trying to generate prime numbers between I guess 100,000. So if we go back into the code, it's just a simple input. It's just a simple input with a button. So if you go back, it's just this input and this button and nothing. So in the main, what we are doing is that we want to run a function that generates prime numbers. And I just want to show you the challenge of like JavaScript being asynchronous. So this is just like synchronous code, sorry. So we are just trying to generate, and let me pull this down. We're just trying to generate prime numbers between 1 and 100,000, and we're just going to store them in an array. So it will go over all the numbers. Complex, don't worry about the code. I'll share this if you want to look at what it's doing. But because JavaScript is synchronous, it's doing one thing at a time. So first of all, we want to run this function. We want to push things into an array. And so because JavaScript is synchronous, we have to wait for all the things to finish before we can actually do anything. So if I come here and I click on generate prime numbers, It's generating the prime numbers. Now you can see that all the time that it is generating, I'm trying to click, but then I can't do anything. Like I'm genuinely trying to click, I'm clicking the input, but I can't do anything until it has finished generating. So if I reload and I try to generate, I'm clicking, nothing is happening. Because what is happening is that when one thing is running, it blocks off everything. So you can't do anything else until the program is done. Now that it has finished generating, when I click, it works and I can do things. So that's the challenge of JavaScript being synchronous, is that by default, when things are running, it will stop everything. So when you have an application and things are running, everything will stop. You can't even click, you can't even scroll, you can't do anything. You have to wait till everything finishes before you can do anything else. So that's what we mean by JavaScript being asynchronous. Okay, I hope that example wasn't too confusing.
No.
Okay. So that's just to show you the challenge of async. Sorry, I hope I'm not. That's to show you the challenge of synchronous programming. Now, the way we get around this is by making JavaScript asynchronous. Now, I guess you might ask, and these are just some examples. I have them in the slides if you want to test them out. So in this same example, where we were logging things and it was taking a while, we could do the same thing by using an asynchronous web API like set timeout. So we haven't gone over set timeout yet, but just to show you, and if I close this. So this is just the first one. So we are doing one thing at a time, but we could use a web API like set timeout, and we'll talk more about web APIs today. We could do the same thing. So if I comment out this, and I'm saying starting, and I'm saying set timeout, wait for 2000 milliseconds, console log not done yet. By default, if I wasn't using this, how it has to run is that it has to do this, console log the done, and then the last thing will be not done yet. So if I comment out this one and I just do it synchronously, I can console log starting. Then not done yet, console log. I mean, it's almost the same thing as the one above, so I don't need to. But then console log not done yet because I'm waiting for two seconds. Then run done. So let me just run this. So by default, it's supposed to run 1, 2, 3. So line 10, line 11, and line 14. But asynchronous web API like set timeout is asynchronous. So let's see what happens if we were to run the same code. And let me make this bigger. If we run the same code, so the first thing is starting. When this function is done running, it's supposed to be done. And afterwards, it should be, let me just change it to EA. So this is supposed to be the last thing. Now, if we run this, we can see that that's starting, and done. Now, the reason that is happening is because set timeout is an asynchronous web API. So because this is waiting 2 seconds, when our function first, or when our program first that goes here, it's just console log starting. But when it gets here, it sees that I have to wait 2 seconds. So instead of waiting for the 2 seconds and blocking everything, let me move on to the next thing. So it moves on to this console log here. So we can see that then it comes back after it is done running all the other things. By the time it comes, the 2 seconds they had to wait for this one has passed. So now we can console log done. So it's not going to wait for the 2 seconds and run this before it will come. I mean, 2 seconds is small, so maybe it might not. But imagine if this was maybe 10 minutes, and I don't think we have 10 minutes. Imagine this was 5 seconds. It means that our program has to stop, wait for this to get to the 5 seconds before then it will move to the next thing. But if we use like an asynchronous web API like set timer, it doesn't have to wait for the 5 seconds. If there's any waiting time, it'll just skip to the next thing, go and finish executing that task. And if the task it left has now finished, it'll come back to it and do what it has to do. So if you run this again, We see that starting, then it skips the done because it's not done yet, goes to the A, finishes everything, now comes back to the done because now it sees that the 5 seconds is done and it has executed. Does the example make sense?
Yeah.
Okay, so that's how asynchronous programming can help us and make our program more responsive and it won't block everything. Now you might ask, why is it that when we're in the browser, and you might ask, why is it that when we're in the browser and we are doing things, everything is not blocking? Because we are saying that JavaScript is asynchronous. Now, the reason why when we are browsing and stuff like that, like when we click on stuff or when we are loading things, our page is still responsive is that by default, the environment we are running our coding comes with some asynchronous things that is usually handling all of this. So most times we are running our program in the browser. I mean, when I was in my VS Code, I was running it in another environment called Node. We'll talk about Node in a future class, but most times we are running our program in a browser. So by default, the browser has asynchronous web APIs, which is usually handling all of these things in the background. That is why when you make a request, the whole page does not freeze and you can't do anything because you have like some web APIs which are doing the magic or doing all the work behind the scene. So by default, JavaScript is synchronous. But then the reason our page doesn't block is because of the environment we're running our things in, which is the browser. Browsers have a bunch of APIs we can use that are async and enable us to keep looking at other things while the operations are being processed in the background. So you have an example of like set timeout, you have an example of fetch, and other things like that. Okay, so we can slowly take our time, and if you have any questions, you can ask, or if anything you just want to clarify.
Yeah. Can you go over this last part again?
Okay, so when we looked at the example, when we had this, when we had this example, and if I escape and I go here, when we had this example of the generate prime numbers, when we started generating prime numbers, and let me just I hope, okay. When we were generating prime numbers, okay, I guess I changed, let me make it more. When we're generating prime numbers, we could see that with the time so I'm clicking, this is me clicking. We could see that nothing was working because it is waiting for the function to finish running before you can do other things. So by default, that is how JavaScript is. When one thing is doing it, you can't do the next thing, so it blocks everything. And we're asking ourselves, so then why is it that when we are on different websites or browsers and we are doing stuff, when we click on something or we're waiting for something to load, we can still do other actions and our page doesn't completely block, like my example where now I can't even click on anything because it has blocked the whole thing. We said the reason that is possible, or the reason everything doesn't block when we're waiting for one thing to load, is that by default, the environment we're running our code in, which in most instances is the browser. So the browser is an environment. The browser has things going on in the background that is allowing our code to run. But the browser has a bunch of APIs, web APIs, which are asynchronous. So they are handling of the blocking stuff. So it's pushing, if something has to wait, it's pushing it that move to this side, move to this. So it's actually pushing things so that the things that are going to take time to run, they don't block everything off, that we are unable to click, we're unable to move, we're unable to scroll. Because if it was just going to do JavaScript without the asynchronous stuff, if a page was loading, we won't even be able to scroll. We won't be able to click. We can't do anything. The whole page will block. But the browsers have APIs which are async and they enable us to keep doing things, keep scrolling while we are waiting for like the page to load or whatever operation we're doing to be completed. And some of the examples of like web APIs are set timer, fetch, all those things. We'll talk more about them. Yeah. Any questions, please?
No, it's good. It's good.
Okay. Now the one thing which is like very magical is that you learn that well, the browsers are actually doing stuff which is making like the program asynchronous. Like the browser is like mind blowing, like it's doing so many things. So when we did like fetch, when we're fetching, it's like something that comes as part of the browser spec is the browser that allows us to fetch. The browser allows us to do all those other things. So the browser is like doing a lot of the heavy lifting. And so, but we also need to be able to know how to handle these responses that comes back from the browser. So if our code is asynchronous and the browser is doing all the heavy lifting in the background, we have to know what to do with the response when that operation is done completing. So if we're making like a request and the request is done, we have to be able to handle what we want to now then do with the request. And that's what we want to spend some time talking about. So we're going to need to know how to handle the responses that are coming back from those web APIs. So for example, when we made the fetch request, we said that our browser will keep running because then it makes the fetch asynchronous. So it will keep running so that it doesn't block everything. But then when that fetch is done, we have to be the ones handling it. We have to code out to handle what we then want to do after those operations are completed. So the way we do that is we use what is called a callback. We can use promises, and eventually we'll talk about using async awaits. So we'll take them one by one and go through all of them individually. Okay. Okay. So we spoke about event handlers, and we spoke about one example was like add event listener. Now, one thing maybe you didn't know now, but now you know is that event handlers are really something that comes as part of the browser spec. So they are like asynchronous. So think about it. We said events are things that happen. So when they happen, then we do something. So the way events in some ways are like examples of like asynchronous programming, because then they only fire off when something has happened. So when you have something, then you do something. So events are really a form of asynchronous programming. You provide a function that will be called not right away, but when an event happens. So it won't block off everything right now. It will only come into action when you have something. So the same way when we're running the code and we use the set timeout, it didn't block everything. It kept moving on to the next thing until the set timeout had completed, and it will now come back to it. That's the way event handlers are really working. So they are not blocking off everything. They only fire off when it actually has something. So when it actually has something inside of it. So if it had nothing in it, the code, your program will skip it, keep running that other thing. It won't block it and wait for the event to actually have something before it runs the next thing. So that is how event handlers are. And a callback is just a function that is passed into another function. So when we're doing event listeners, we said first we add the event, then the next thing we were passing in a function. So if we have that event, what do we have to do? So what we have to do, that thing is called a callback. So a callback is a function that you run, a function that is passed into another function. So you can see and if I open this, add events listener. So we said document was an object, and then we said add event listener, and this might be difficult, but if document is an object, what would you say add event listener is? No pressure.
Again.
I was like, so we said the document is an object. It's an object. So
Come
for
again. Okay. Okay. I didn't hear the
yeah,
question.
can you hear me?
Yes.
So when we did the user, we had, maybe I shouldn't have deleted it, but we had like name, Tom, because I don't want to. And I always, I'm sorry, I like using equality, but we had name, and we had, let me just copy this. I'm lazy typing. Age 12, and we had like get time, and also we can do a function. Function something. I mean, we don't want to do anything. We just want to just try random things. And This is supposed to be here. So when we had this, we said this was a user object, and the user object had like this was a property, so we could use the dot name, and this was a method because it is a function. So it is a function tied to the user object. So it's something like user dot get time. So that is a method tied to the user object. So in the same way, I'm saying that by default, we are saying that the documents, when we open our program in the browser, it is rendered as a document, which is a representation of our program, and it is an object. So I'm saying if the document is an object, what is this add event listener? What is it? And the clue is somewhere up there, I think. I don't even know what the answer is, but what do you think? I mean, just guess. Take a wild guess.
Method?
Yes, it's a method. So
Oh.
it's a method. So by default, all the things we are using are just methods that comes as part of the browser. So the browser is allowing us to do these things. So add event listener, query selector, so document, so the document object dot query selector, all those things are just like methods and objects. We did like dot inner HTML, which allowed us to change like the all these things are, so in essence, it's just an object with different like several properties and methods. Then we are just using them for different things. So when we're adding event listeners, that is just like a method that comes with the document object. And if I were to go into my browser, and let me console. If I go into my browser and I console.log, if I console.log, and I'm just hoping that I'll tie everything in together so that I'll start to make if I console log this, you can see that it comes back as a big object. Now, so it's an object, but with the object, it has so many properties and methods. So all these things are like properties and methods that comes as part of the object. So we can see something like on drag, on close, on click. We can see things like, let's see some of the things we've been using. So like on click, if you can see, you can see on click. So when you click on something, on play through. So all the things we've been using are just things that are part of the document object. So all the properties and methods are the things that we can then use to do something. So event listeners, all those things are part of a big object, which is the document object. So it's the same way we can create our own object and give it properties and methods. It's the same way the document is an object and it has different properties and methods. And then we can use those properties and methods to do different things to our document. So event listener is a method tied to the document object, and we can use that to listen for different events. There are different events that we can listen for. So in essence, it's just the same thing that is like tied around and things like we can see that the document has a property called title. So if we were to do title, we'll get the title of the document. We can see that, and I hope you can see, I hope it's not too small. Let me zoom in. We can see that it has a doc type. It has a property called doc type. So all the things we've been doing are just like properties, methods of objects. So it's the same thing. So when you understand this, then it starts to make sense that it's just the same thing. You're just playing with it in different ways. It's not like very new things. It's just the same things which are appearing in like very different ways. So when we talk about an object is just a key value. An object is just like a collection of key and value pairs. So an object is like sort of a storage that stores keys and values. It stores keys and values. And we said a key can be a property. So a property are just like variables. So we can use the dot to access it. So that's why whenever we are doing document, and if I go back, that's why when I do add event, I use the dots because then I'm trying to access one of the methods that is in the document object. So think of if we were to create our own document, I mean, we can't create a document object because we already have a document, but if we created a document object, by default, we are saying that it has something called add event listener, and the add event listener has something. It does something. We don't know what it does, but we know that we can use maybe I mean, here is more descriptive, but it allows you to add events. So you want to think about it like this, that the document has a property, a method called add event listener that is allowing us to listen for events. It has several other things, but under the hood is just an object. It's just an object that is doing like fanciful things. So I hope it's starting to click. It's starting to like
Yeah.
little light bulbs are starting to go up that, oh, so this is what we've been doing the whole time. We've just been accessing properties. We've just been accessing methods, and it's just an object. Everything is an object. Everything is an object. The one thing they always say is that in JavaScript, everything is an object because you're just like playing around with properties and methods. So yeah, so I mean, like you can see, when we just console log the document object, we can see all the things that comes with it. So all these other things, and we can just access it and do different things with it. So we're at the top of the hour, so we'll just take a break. Then when we come back, we'll learn how to use the subject and handle like make our code asynchronous, because we said that by default, if it's synchronous, it's blocking stuff. But then we can make it asynchronous where it can do other things and then come back to do the thing that needed time, the thing that it had to wait for. But now we're saying that after that thing that had to be waited for is done, how can we handle that? How can we use the result to do something else? So when we come back from the break, we will talk more about it. So I'll just go ahead and start the time. I hope it's starting to make sense a little bit.
Yes. Yeah. Yeah. Can you hear me?
Yeah, I can hear you. I can hear you. I can hear you. So I,
Uh-uh.
I'll see you back in 5 minutes. So walk around, stretch your legs, anything you want to do. Hi, can you hear me?
Oh, no, sorry.
No problem, no problem. I'll be at a good break.
Yeah, I think my headphone disconnected.
Okay.
My
Yeah.
headphones were disconnected because I was 2 floors down.
Yeah. So just to get back into before we get back into any questions.
No, no.
Okay. So just to go back into it. So when we spoke about a synchronous function and we looked at the one that was generating the prime numbers, we said that by default, the way our program usually works is that it steps through one thing at a time. But then if we have like a long synchronous code where like it has to wait for one thing for a long time, it makes things unresponsive because then you can't do anything. You have to wait for that execution to finish before you can then move to the next thing. And that is not good for user experience. So what we want then is we want to start a long running operation, what we call a function, but we want to have a function so we want to have one that is doing it and returning the result immediately. But then if it has to wait, we want it to be able to skip it and keep the program still responsive to other things. And when it is done running, that it can notify us with the results when it is eventually done. And then we can come and do something with that result. So if we're waiting for it to add something, we don't have to wait for it to finish adding before our program, we can do things. But even while it is running in the background, we want our program to still be responsive. Then when it is done, we can take the results and then do whatever we want to do with the results. So that is when we say callbacks come inside. And we said callbacks come into question. And we said callbacks are essentially just functions that we pass into other functions. And then for an example, they are just functions that is passed into a function. We're talking about the add event listener property, or the add event listener method, which comes as part of the document object. And we said that usually the way we usually run it is that usually we have an event, and when the event happens, we do something. So it's sort of asynchronous. Our program will keep running until that event happens. Then when the event happens, we do something. So if you always forget how to write event listeners and stuff like that, because it might have been confusing in the past, always know that usually you have the event, then you have a callback. So the callback is just the function. I mean, you can either write the function directly, and just to digress a bit, you can usually write the function inside directly. So document, or let's say we just want to add event listener, the event we want to listen for. So the first thing is always the event we want to listen for. And the next thing is just the function we want to run. So if you want, you can write the function inside directly, function say something, or you can just write the name of the function here, say something. And then you can come and define the function somewhere. Now, the reason this is fine is because by default, it is asynchronous. So add event listener is async. The event listener is async. So this won't start running, because then if it started running, it'll block everything waiting for this click to happen. But because it's async, this add event listener is async. It only run after something has been clicked. So that's why we don't call the function. So let me show you something. Say something. Say something. Let's say console.log. I said what I said. Okay. So usually when we are calling a function, we write the name of the function and we add this. So this is how we call a function, right? I hope. Yeah, we call, if we want to call a function, we just write the name of the function and we call like this. But when we are adding it to event listeners, the reason we don't call it is that when we do it like this, it means we are calling it immediately. But then we usually only call it when the event has happened. That's why we don't add the parentheses. We just leave the parentheses because we don't want the function to run immediately. We only want it to run when our event has happened. So just a little digression to show you how callbacks are an example of a callback being implemented. So back into the slides. So a callback is just a function that is passed into another function. So the way this works is that the way callbacks work is that because we want our code to be asynchronous, callbacks are only called when something has happened. And so for this example, we want to add numbers. We want to add numbers. So we want to do step 1, do step 2, do step 3. All step 1 is doing is that it's taking a number and adding 1. Then we are passing that result and we are adding 2. And we are passing that result and adding 3. Now, what this will do is that, first of all, it will add the 1, but while it is waiting, it will go on and keep going on and doing the other thing. Now, as you can see immediately, it's very confusing. Like, your eye is going all around. It is confusing. This is what we call a callback hell. So callback hell is essentially when you nest several functions because you want them to be async. So you want to like keep doing things until everything is done. So we call it a callback hell. And most times you don't have to write code like this. This is like an old way of writing code. But just to show you, this was a formal way of like making it async because then we want to keep getting the result and keep using them so that our code is not blocked. Now, a better way to do this is what we call promises. So promises is just like the English word promise. So you make a promise to someone. If you make a promise, what you're saying is that like I'll do something for you at a later date. And in programming, that is the same idea behind a promise. A promise is that I don't have it right now, but then when I have it, I'll do something for you, or I'll do something for you on a day. I'll do something for you, but not right now. I'll do it at a later date. So that's how you want to think of a promise. So usually when we nest callbacks like I did, it can be hard to read. Like it's hard to read, it's hard to understand what you're doing. And it's easy for you to have like bugs. You can have like a lot of errors and it becomes hard to handle errors. So the way you usually like to do it is you want to use what we call a promise. Now, what is a promise? A promise is an object. Now you start hearing objects a lot, but when you hear an object, I hope in your mind you can sort of picture what an object is. Key value pairs. You have a key, you have a value. You can have properties, method. So it's an object. So a promise is an object returned by an asynchronous function, which represents the current state of the operation. I'm just reading it. I will explain it. At the time the promise is returned to the caller, the operation isn't finished, but the promise object provides methods to handle the eventual success or failure of the operation. So all a promise is that a promise allows us to run asynchronous code by saying that if you're running a function right now and you don't have the response, it's fine. Move on. Now it is a promise. Keep moving on until I'm done with it. When I'm done with it, I promise that I'll give you back the result and you can do something with it. So a promise is an object that will be returned in the future. It's not returned immediately. So don't block my code. I'm giving you a promise that you keep running it. When I'm done running this kind of thing, you can come back to it and we can use it for whatever you wanted to use it to. So like it says, at the time the promise is returned to the caller, the operation isn't yet finished. So it isn't yet finished. But then the promise object provides methods to handle the eventual success or failure of the operation. It sounds plenty, but this is something we've seen before. And when we get back to it, it'll start to maybe click. But so far, any questions? And I'd like to ask if we have any questions because I don't want to. I don't like talking first of all. Plus, I don't want to be saying things that are not making sense. Yeah.
Yeah, maybe an example will help to make it more clear to me.
Okay, great. So, I think I've skipped one slide. So go back. Okay, so we're saying an object. So a promise is basically an object that may have a value in the future. So right now it doesn't have anything, but then it might have a value in the future. So promises have like 3 states, and this is just knowledge, things that you should know. I mean, a promise usually has 3 states. So when you initialize it, it has the initial state. It hasn't done anything yet. Fulfilled when it is done or when it is rejected. And if we go back into our code and we try to see what is happening, and I'll just open up the code again. Give me a second. If we go back into our code and we try to implement what we've been talking about, Okay, I'm just opening like this. Okay, so I'll create a new folder and I'll just zip everything as always and I'll just share it. So let's talk about promises and let's create a new file, index.html. And then let's create a file main.js and I'll just share the it's taking a while to start. So yeah, I'm just starting it up. I'll share the link for you if you want to jump. Whilst we talk about promises. Okay, so I'll just share this. One sec while I try to share it. Okay, I just shared the link. It should be okay. Yeah, I just shared the link, so you should receive it soon. Okay. Okay. So uh okay, so now we're talking about promises and ways to handle async code. So we're saying when we make code async, it means that by default, it is not going to block it. It is going to skip it to do other things. And then when the code which was skipped is done running, it will come back to it and do something with it. But then we have to have a way to handle that thing so that when the async code is done running, how it is handled. And we said one of the ways we can do that was callbacks. I mean, we looked briefly at callbacks. And we looked at callback here where you nest a lot of callbacks. So we said callbacks are just functions that are passed in other functions. And callback here is when you have like so many functions nested inside of each other. But we said there's a better way to do this. So if you have a sync code running, we are looking for a more readable way to handle a sync code. And we said we could use a promise. And we said a promise is just a promise, like the way it is. It's just an object that represents the eventual completion or failure of an async operation. Now, the way we usually handle asyncs or the way we can usually do that is let's use the fetch API. So the fetch API allows us to make HTTP requests so we can fetch data from other stuff. And we spoke about APIs briefly. We said APIs are just interfaces that we can use to do stuff. And I have an API. I mean, the last time we used the Doxio API, but today maybe, okay, I mean, we could try the Doxio API, but I mean, we could use this API. It's for an advice. It gives advice. So hopefully we'll get good advice. So we have this we have this API where we get advice. So if we just, first of all, let's just console log what we get back from this API. And if I close this, so fetch is just a web API. By default, it is part of the document object. It's part of the browser specs. Now, the reason we don't, so you could do like document dot fetch, and I think it should work. But the reason for those ones, we don't usually add the document dot fetches. It's so used, and I don't even remember the exact reason, but for those ones, you don't need to add the document dot fetch for those web APIs. I'll look up the reason later on, but the point I just wanted to make is fetch is one of the things that comes with the browser spec. So we can use fetch to make API requests. Is almost similar to like the set timeout we're using, which allowed us to wait a couple of seconds before doing something. So we can use fetch to make requests to an API. By default, when we're making requests to an API, because we don't have the data readily available, it's going to go somewhere, go and get the data. So it has to be async. Because if it wasn't async, it means that while it is going to get the results, our application has to block. We can't do anything. But by using these async web APIs, we can continuously use our applications while we are fetching stuff and things like that. And we said what we want to do is we usually want to return a promise. I mean, we could use callbacks and stuff like that, but what we want to do is we want to use a promise. And we said promises have 3 states: pending, fulfilled, and rejected. Now, the first way we can handle a promise is that we can use what is called a .then. So .then is just a promise object method. So a promise is also an object. Everything is an object in JavaScript. The promise object has a method which is called .then, and we spoke about it briefly last week. The .then is just a method that comes with the promise object. Now, what the first .then allows us to do is that it is when we make this request and this request is resolved. So if it goes through, what do we want to do? So if we do, what do we want to do with a promise that comes? Like, what do we want to do? So that is what usually goes into the first .then block. So again, whenever you see the dot syntax, it means that we are accessing a property or a method from an object. So most things that we'll be doing are just like taking things of an object and method, which is so fun. Maybe not fun right now, but then when it starts to click, it's like, wow. I mean, we're just doing the same thing in different ways. So the first thing is just whatever value the promise object gets, we are passing it. So usually whatever I get, so you can just like write value here. So whatever this promise returns, what do we want to do with it? So, and we said usually for like, and in API instances, usually the API will just return a JSON data. So usually you just want to pass the data into JSON. So, and if you see again, the JSON means that it is just a method that comes with this promise object. So that's why we're accessing it with dot. So all the things we've been accessing are just properties of method. And I said usually you just want to call it like maybe response, just so that you don't get confused. So first of all, this is a promise. So we are fetching. So the reason it is a promise is because by the time we are fetching, when our program runs it, because we don't have this data right now, it's not going to get it. So it's a promise that I'm going to do something. I'll come back with a response, but we don't have that response right now. So we'll say it's a promise. And the way we handle promises when we are using .then is that this is the first promise. That's what do we want to do if this thing is successful? So the first thing we want to do if this promise is successful, this is a promise. I'm going to fetch, come back with something. So it's a promise. If the promise is successful, what do we want to do? We want to pass it as JSON. So we want to pass the response as JSON. And then after we've passed it, so again, by the time it is passing, we don't have the past data. So it's still a promise. After it has passed, what do we want to do? We want to do something else. So it's still a promise because until we have the data, everything we are doing now is a promise. So we don't have the data back. So if we do, what we want to do. So the first dot then, this dot then is the first promise that we want to pass the data. So we want to pass the response. So if this promise is fulfilled, what we want to do is that we want to take this, and maybe we can console.log it. Let's just console.log the data. Any questions? Should I go over it before we run this? Any questions? Does it make sense?
Not entirely.
Okay, you can ask any questions that you want.
The second then part, like line 3.
Okay, so maybe let me comment this out. Let's store it in variables and try to step through them one by one. So we're making an HTTP request, which is an example of fetching something from an API or anywhere. You could be fetching from a server anywhere. But here we are just fetching from this API. Because we don't have this data readily available. When we make an HTTP request, we are sending like a request message to a server and it'll send back a response. In this case, we'll send a request to get the JSON file from the server, like we're making the fetch. But when we get it, we want to do something with it. So we're saying that a promise is just something that we'll get in the future. We don't have it. It's an object that will be returned. So until we have it, because we want our code to keep running, we are just sort of handling it. So we are handling the request. So it's a promise. So you can think of the fetch as a promise. So let's do something like const fetch promise. So we want to fetch something and we don't have it yet. So it's a fetch, but it's a promise that I'll go and fetch this thing and I'll bring it back. But since we don't have it, we take it as though it's a promise. Until we have it, we don't have anything. So if I were to console log this fetch promise, and I'm just saving it in a variable so that at least we see what we are doing. So this fetch is a promise because it's going to do it and come back. We don't have the data. So if we run this, and let me open this in the browser, and let me add my script main.js. I guess let me just call it promises. And let me just give a title h1 promises. So if I open this in the browser, okay, so if I open this in the browser, if we check, and I console logged it, so we can just check our console. Console. We can see that it says it's a promise. Now, the reason it's saying it's a promise is that it's now going to do it. Now, I mean, right now it's done, so it's saying that it is fulfilled. But if we go back into the code, why is this taking so long? If we go back into the code, now, first off, just to go over, do we understand I guess the general definition of like what a promise is?
Yeah.
Okay, so we're saying that a promise is an object returned by an async function. By the time we call the function, the promise isn't finished, the operation isn't finished, but the promise is just a way of like handling it. So if it is done, what will we do? So it's just an object that provides a way to handle it. So if I console log this fetch, we can see that the browser says that this is a promise. So if I go back into the code, we can see that it says that it's a promise. Now, we said a promise has 3 states: fulfilled, response. I mean, it's fulfilled because it has it has completed a code. Now we're saying that because it's a promise, we have to keep handling. So now that it is fulfilled, in this instance, it's fulfilled. If we don't handle it, the promise has been fulfilled. But what then do we do with the code? We are not doing anything with it because our program kept running because it currently didn't have this data. So it would have skipped it and kept running. But then if this promise is fulfilled, what do we want to do? So that's what the first .then block is. So this promise, what do we then want to do with it? So the first .then is usually after we've gotten the promise or after we've made a promise, if we get if it's a successful, what do we then want to do with it? What do we then want to do with the fetch promise? So we could do a fetch, and it's the same thing that we were typing, but I mean, if it's confusing, when we're done, we just write it. So we can do a fetch promise .then. So after we are done, we want to take the promise and do something with it. So we want to maybe, I guess, take the response that came back. So do response, and then, and this is just like an arrow function. So it's just an arrow function, and you could do it like this. But usually when you're doing callbacks, you don't type like function response. Then so that is what we are doing. Like, so it's a callback. So when we get the function, what do we want to do? So we want to take it and do something, but we are just using an arrow function because usually for when you're passing things, so it's simpler and it's less like syntax. So we want to take the response and we do an arrow function. So if you don't remember arrow functions, just to show you arrow functions, let me just do 2 examples, regular, and I'll save the file just so that you have examples. Regular functions. A regular function can be function name, then do something, maybe console.log, hello, and an arrow function with replicating this thing as an arrow function is maybe, let's just store it in a variable called const name. An arrow function will just be this, and then we could just do like console.log name. I mean, it's just one line, that's why I didn't put it in brackets, but you could also do like the same thing like this. I cut it. X. You could also do the same thing like this, but I guess it's just one thing. But so this is an arrow function, and it's the same thing as this. So it's just like declaring a function without the function keyword. So these 2 things are just the same thing. So that's exactly what I'm passing here. So I'm passing here, and here I'm taking like the response, and I'm doing something with the response. And so usually it comes back as JSON. So you want to do something with it. So for instance, if I just console log it, let me just console log it. Let me just console log the status, and maybe this is so that this doesn't confuse us. I'll move it back up. No, let me cut it. Let me create a new file called arrow functions, and let me paste it inside, just in case you want to refer to it. Cheers. Okay, so I'll save it so that I don't delete it completely. Okay, so we're saying that by default, when we make the promise, it's going to return an object. So there are 3 states. It will either be fulfilled, it will either fail, or it will be successful. Yeah. So if we make the fetch is essentially a promise, and when we console logged it, we saw that I returned a promise. So the first .then is what we want to do with that promise. So we want to handle the promise. So the first .then is usually how we are handling the promise. And here, if I just maybe console log the status to see if it was successful or not, so I could just like console I could console dot I mean, we'll handle it, but just to show you what is happening. Let's response. And we could just check the status. So response dot status. So just to check the status, if I refresh this, did I okay. Okay, so it's making the request. I hope it is. If I Oh, sorry, I deleted the first console log. So let me just console log the promise, just so that we see it. Console.log fetch promise. Okay. So we can see that currently it's pending because then it's still making the request initially. But now it has returned a response of 200. Response of 200 means that it's successful. So initially, when we make the request, it hasn't completed. So we can see that it is pending. But then when it is done, we can see that, oh, now it has been fulfilled. But then because now the promise is done, our first dot then is like how we want to use the promise based on the status. So if it is successful, what we want to do with it. So that is what we are doing in the first dot then block. So the first dot then, we want to take it and we want to just pass it as JSON, because we said usually it comes back in, and I guess let me just console log the response so that we see how the response is coming and see why we need to pass it as JSON. So if I console log the response, if I go back here, if I refresh, so we can see it is pending. Now it is pending, but now it has completed and it has returned a big object. So this is what it returned. This is what the response is. Now let's see the difference if we pass it as JSON. And I guess let me just copy the same thing. And usually if you're doing things and you want to see what is going on, just keep console logging, see what it is doing at every stage. That's like the best way to debug. So if I console log, this is the initial response. So after the promise is done, I'm saying that take the fetch promise and then console log the response. So if I go back into the browser, first I have a promise which is pending, and then I have a response. Now, when I pass it as JSON, it becomes a promise again, and it has returned an object. It has returned an object which is passed. So this is like a JSON object. So the difference between this response is that this response is just a big object with everything. But then when I pass it as JSON, it just returns like an object with just the main thing. So it's not taking like the header. If you don't pass it, it brings like all other you might not need, like the header, status, things like that, but you don't need it. But if you just want the main things in the object, you pass it as JSON. When you pass it as JSON, it will just extract the main information you actually need. So that's why you pass it as JSON. So when I console log, you can see the difference. This is just returning the headers. It's returning the status. Status just means if it was successful, 200 is success, 400 means failure. There are so many things. You can just Google them. So, but when I pass it as JSON, it returns a promise. But the promise is an object which has extracted the main information that I need. So because it is a promise, I have to handle this promise too. That's why we have a third dot then block. So first, I want to just pass the response as JSON. So when you pass it as JSON, what you are doing is you are extracting the main information from it. And when I pass it as JSON, like we saw here, when I pass it, what it returns is a promise. The reason it returns a promise is that when I'm passing, I don't have the data. I'm now going to do it. So I have to return a promise. So now I have to give it what to do after that passing has been successful. So if it successfully passes the data, if it successfully extracts the main information, what do I then want to do? So now you can take it and then do what you want to do with it. That's why I have like another dot then block. So then dot then, after you've passed it, what you have, you can call it anything. So, but we can call it maybe data. And now if we wanted, we can like maybe put the data on our page. We can console.log data. So now if I run this and 1 second, let me just, sorry, I might disconnect for 5 seconds. I'm plugging in my charger. But so far, is it starting to make sense a little bit?
Yeah, that's my bit.
Come again? Bit by bit,
Yeah,
yeah.
yeah.
Yeah. So now if I get the data, what do I want to do? So that's what the third.then block is. So if I, okay, we're already console logging. So if I refresh this, first off, we have a promise. Why is it saying undefined? Line 16 says undefined. Are we in the right block? Console log data. .then data. Okay, let's just refresh this again, see what happens. Okay, so we have a promise. It returns undefined. Okay. Let me see why it's returning undefined. Did I spell something wrong? Pass the response as JSON. So then, okay, I see what's happening. Okay, so I mean, I see what is happening, but just so it's not confusing, let me just type everything in one line. So I mean, I was breaking it down just so that it will be easy to understand what is going on. So we want to fetch from this API, fetch. Do I have more quotation marks than I need? Okay, so we want to fetch, and we know that when we fetch or return a promise, so what we then want to do is we want to handle the promise. So first of all, this will return a promise. Then we want to take the promise, whatever I return. So let's assume that what we return, want to call it a response. So we are passing in a callback and we want to pass the response as JSON. The reason we want to pass it is, like you saw, by default, when the response comes, it has like every information, like how it got the data, what the status was, if it was successful. But you don't need all that. All you need is the main information. So when you pass it, it just extracts the main information. So we want to pass it as JSON. And after we pass it as JSON, what do we want to do? We then want to take it, because we know that when we are passing it or return a promise to, because it is not done completely. So we want to take that and see that when it is done, the data that it has, I mean, for now, let's console or log it, because we don't have anything that we want to do with it. We don't have any application built. So if we run this and if I comment out all of this, and we refresh, now we can see that what we have, our data that we have is, they give us an advice. Remedy tickly coughs with a drink of, I don't know what kind of advices, but if they said remedy tickly coughs with a drink of honey, lemon, I don't know. If we refresh again, hopefully we get a better advice. So it's making the request. Now I'm not console logging it, that's why it's not logging anything, but we get an advice. Walking is a perfectly valid solution to traffic congestion problem, which is true. I hope the people of Accra will learn to walk and not drive. If we refresh it again, we get a new thing. It is always impossible until it is done. So just to go over it again, we said when we fetch, by default, what happens is that we get when we call the fetch API, because we are running asynchronous code, what we are getting back is a promise, because by the time we are calling it, we don't have the data readily available. So it is a promise. A promise has three initial states. Either first it is pending, so it is now doing it. It can be successful or it can fail. So if it is successful, what we then want to do is that we want to take whichever response that comes back and want to pass it as JSON. The reason I'm passing it as JSON is because I just want to extract the key information. I mean, if you wanted everything like the headers, the status, you want to use it for things like that, you could leave it, but we just want the key things. So we can just pass it as JSON. And then after we've done, we know that while it is passing, because we don't have it readily available, this will also return a promise. So we want to then take this promise and then say that after it has done that, the data that we have, we want to do something with it. I mean, we don't have any application built, so I'm just like console logging it. But that is just the whole sequence of like what is going on behind the scenes when you're running asynchronous code. So first you have a promise, then you have to handle what you should do when the promise is successful. Now, the one thing you usually want to do is that when you add a promise, you want to usually add a dot catch. So a dot catch is basically what to run if this thing fails. So if it wasn't successful, what do you want to do? So usually you just append a dot catch to it. And the dot catch is just like, if there's an error, what do I want to do? So for example, I'll just add a dot catch. And this is just something that you will just always add, because right now we're just assuming that it's going to be successful. But then if it wasn't successful, what will we do? So dot catch, and it's just the same way we've been doing it, dot catch. So you could just pass like maybe so assume that if there was an error, so if the data is not coming back, it could be an error. So we could just like console.log error. And just to test it out, I can maybe change this thing to .con instead of .com. So by default, we know that it's going to fail because we know that the API is .com. So if we run this again, we expect that it will fail. So we can see that it is console logging the error. It failed to fetch because then it can't find. So it says that name not resolved. So the promise was not resolved. So if we open it up, type error failed to fetch. So it means that I wasn't able to fetch. So that's why we like to add a dot catch so that if it fails, we know what to fail. But if I change it back to .com, hopefully it'll be successful. You see, it's taking a while because it's fetching. So it's returning the data. Accept advice. Wow. The advice they gave us is that we should accept advice. So this is just like an API with a lot of advice. So every time we fetch, it's just taking a random one. So we could use this to build an application. And I think when I mean, a while back, I built an application. I don't know. I think it was called Get Good Advice. And let me see if I can find the link. I've used this API a long time ago. I built an awful application, Get Good Advice. I mean, I was just testing out the thing, but I guess I had some time on my hands. So I built out an application where when you click on a button, it gives you advice. So I built this a long time ago. It's awful, coded by Cornelius. Click on the dice to get an advice. So when you click on it, it'll make a fetch request. So behind the scenes, it's just the same thing we've been talking about. I don't know if I'm console logging anything in my application. Yeah, so I guess I was just console logging what is coming, the object. So say sometimes you need to say sorry, even if it's not your fault. So every time you click on it, or just make a new fetch request, make choices, don't look back. If you think nobody cares, you're alive. If you think nobody cares, if you're alive, try missing a few payments. I guess that is true. If you miss a few payments, people will care. So just to quickly go over this, I mean, we have like 12 more minutes. So when we're handling asynchronous code, by default, JavaScript is synchronous, so it blocks things. But then what our browsers and the environment we run our code allows us to do is that they give us different asynchronous web APIs that allows us to do things that doesn't block our code. So we can still be using our application while some things are going on in the background. Now, one example is using the fetch. So fetch, we are making HTTP requests to different servers. Because we don't have the things readily often, if it was just JavaScript, it will block it. So whilst it was making the request, we can't do anything. We can't move our application. We can't even scroll. Everything will just be blocked. But because of asynchronous programming, we can make these requests and our applications can still be responsive. And there are different ways we can handle the response that these asynchronous APIs bring back. one of the ways was callback else. We didn't really look in depth into it, but another way was to use fetch. Fetch is a web API that allows us to make requests. So when we make a request by default, because we are making a request, we are going to get the information from somewhere. By default, JavaScript would have blocked our application, and then we can't do anything until all these things have been resolved. By using asynchronous programming, we can still continuously do things while this request is going on in the background. Now, what we want to do is that we want to handle these results when they come back. And one of the ways we can do is by using a promise instead of a callback. We can use a promise. Now, a promise is just an object that is going to be returned in the future. So immediately we don't have it, but then we know that it is going to be returned in the future. So what we want to do is when we use a fetch is a promise that is going to be resolved. It hasn't been resolved immediately, but it's going to be resolved. So when the promise comes, the first thing we want to do is that we want to handle it. So we're saying that when the promise object, after the promise has resolved, so after you've resolved the promise, what we want to do is we want to take whatever data you give back and we want to pass it. In this example, we want to pass the data, which is also a promise because it hasn't been done. It is now going to be done. So just think of asynchronous stuff as things that are not done immediately. They take like a little time to do. So it's going to be a promise. So we're going to wait for that to be done. And after that has been done, we can take that, the response that our JSON object returns and do something with it. So if we had an application and we wanted to like put whatever response it brings back, this is where we would, it's in this promise block that we would have been doing that. So for example, let's say we had an H1, I guess we had like a paragraph. We had like a paragraph and let's give it like an ID of para. As always, the same thing we want to do is, I don't want to delete these things, but I guess I'll just move them down. I want to leave them for your perusal. So do I need to? Not really. Not really. It's just the same things that we've written. But then the way we could do that is first, we know that the document is an object. So we want to grab this thing, the paragraph, and do something with it. So we can go into the document object, get element by ID method that allows us to grab elements that have an ID. So it's just a method that allows us to grab things that have an ID. So we want to grab an element that has the ID of para. And what we want to do is that we want to add an event listener. So we could just, I guess, just so it's clear, we can add an event listener to the para. Para dot add. Oh, am I doing something? Oh, let me just add it. Dot add event listener. Then I guess the event listener we want to, we don't want to add any event listener. So all we want to do is, right now, all we want to do is just put the text inside. So let me just grab the paragraph. We don't want to. What I'm trying to do is I'm just trying to, whichever advice that we get, we just want to put it inside our application. So I don't want to do like any event listener. So we just want to take our paragraph, and this is a bad way to do it, but sorry, let me just save a const paragraph is equal to this. So I just want to take my paragraph dot inner HTML. I don't know if this will work, but then I just want to set it to the data. And when the data comes, close, get good advice. When the data comes, we know that the one we want is advice. So the data has a property called advice. So again, the same object. So we can just take this and take the advice property that comes with the object. Let's see if this works. I think I've messed up somewhere, but let's see. Okay, so you can see it says undefined. The reason it's saying undefined is that it's not the way I'm handling it is not really async, like in my HTML. So when I start off, there's nothing because it's now going to fetch it. So that's why I have to like use maybe like event listener or something for my HTML so that it will only run it after we actually have data. Because if I run it immediately, you see it's saying undefined because synchronous is just doing everything it has to do step by step. So it won't even wait for me to finish and stuff like that. So it's saying undefined. So a better way to do it will be to make that one to like async so that it only do that if I actually have like some form of data. So any questions? So this is bad. But I mean, if we wanted to do it, I guess the easiest way to do, I mean, I don't want us to reiterate this, but the easiest way to do it will be like maybe to add a button, get advice, come into this one and type it out. How will we grab the button? Just type it out as practice. It's fine if you, but just practice, hands on keys. Ouch. So we want to grab the button from a document, but you can just save it in a variable. So you can, I guess, let me start here for you. So let's save it in a variable called button. And I'll just go into the HTML. Let me give, I mean, I don't need to, but let me just give it an ID. Let me just give it an ID called button. And it's fine if by just, I mean, how would you just grab it? You can just copy the one on top and just change what you need to change.
Yes. Yeah. I do the right thing. Oh, hello. Can you hear me?
Sorry, can you hear me? Can you hear me? Sorry.
I can't hear you. Yeah, I don't know.
Yeah, can you hear me now?
Yeah.
Can you hear me now?
Oh, it's so to it. Yeah.
Yeah,
Yeah.
yeah, apparently I was muted and I didn't know. Yeah, I mean, so you were trying, I think, I don't know, Windows just interrupted. But I was saying that,
Oh,
like, is it breaking or can you hear me well?
I can.
Okay. No, so I was saying that, don't forget, whenever you're trying to grab like elements from the DOM, so we said that the document has like methods that we can use to grab. Event listeners is when we are trying to add events. So when we want to click and do something. But if we are just trying to grab it, I guess the two primary ways we can grab it is query selector and get element by ID. We use get element by ID if we've added an ID to the element. So the get element by ID is a method on the document object that allows us to grab things from the DOM. So we can go into the HTML and grab elements. So that's why it's get elements by ID. So we want to get an element which has an ID, and the ID is what we describe. Or we could use query selector, which will allow us to grab everything. So if we wanted to grab the button, we could just do like get element by ID button. And don't worry, like these things, the more you type them out, the more you do stuff. So I mean, we could do this, then we could like put in a function. So I guess what I would like you to do is like right now we don't have anything going on in our application, but if you have time, when you fetch the data, you can like add it to the DOM. So I mean, if you need to Google stuff, like how can I add the I guess the advice that I get, how can I add it here as the paragraph? Or maybe whenever the person clicks a button, that advice, I'll just put it in the paragraph. But yeah, I guess that's the main things. Any questions? If not, I'll just go over the things we've discussed then. But any questions, please?
Yeah, I'll go over this last part again. Yeah, I just need to go over that. That's yeah. Okay. Are you speaking?
Oh, sorry, I was muted and I didn't know I was muted again. Yeah, but can you hear me now?
I can't hear you.
Oh, can you hear me now?
Yeah.
Okay, it's starting to act
Mm-hmm.
it's starting to act weird. But I was saying, so I'll share the slides afterwards if you want to go over. I'll share the recording by tomorrow. If you have any questions, please feel free to message me. It's fine. As always, I say it's fine if things don't totally make sense right now. It's new material, so it takes time. But the only thing, just to recap the things we've gone over today, aside the things we recap, we've spoken about asynchronous programming and how to do asynchronous programming. We said the way we can do asynchronous programming is by using callbacks or fetch. Most times you use a fetch. Next time we meet, we'll talk about async await, but a fetch just returns a promise. So because we don't have the data readily offhand, it means we'll get it in the future. So a fetch returns a promise object, then we just handle it. So we use the dots then to handle it. So whatever the value, so here a promise object method that returns after the promise has resolved. So the first dot then is what we run after this promise has resolved, because we know when we console log it, we know that fetch will return a promise. So this first dot then is, and am I doing it right? This first dot then is a promise method that runs after the promise has resolved. So if our promise is successful, the first dot then is what we want to do. And for our fetch, we were just passing the data so that we could extract the main things. So the value is whatever value the promise object, we pass it as argument. I guess I'm also. So just, I mean, go over it. I've shared the link to the MDN docs for like asynchronous programming. Please, if you have any questions, please feel free to message me anytime. Happy to help. So if we understand this is like a core part of programming. I mean, in every programming language, you'll deal with objects. They'll talk about object-oriented programming and stuff like that. So if you understand this, you're like on your way to like doing anything you want to do. So yes, that's about it. But thank you for joining, and I'll see you on the